Before we start third type in exercise 1.3, we have to know two types of functions. First, explicit function, and second, implicit function. Whenever there is y, value of y in terms of x variable, means for example here x cube minus 2x squared plus 3 is there, means here y is expressed completely in terms of x, means y is expressed explicitly in terms of x. This type of function is called as explicit functions. Means y is in terms of x or x is in terms of y, this completely in terms of y. This type of functions are called as explicit functions. Quite often we come across with functions like x cube plus 2xy is y square equal to 0, or y equal to, suppose, sin xy is there. Now in these two types of examples, we cannot express y completely in terms of x or x completely in terms of y. Means such type of functions are called as implicit functions. And whenever we represent this function separately in terms of one variable, such type of functions are called as explicit functions. Before all examples in all exercise are of type explicit function. Now we come across with implicit functions in third type. To solve or to differentiate this type of implicit function, what is procedure? First of all, we have to differentiate this equation with respect to x. What is procedure? First of all, we have to differentiate given implicit function with respect to x as it is. Second step to calculate derivative of y with respect to x is we have to collect the terms of dy by dx. Second step. What is step third? Step third is we have to calculate value of dy by dx on left side. We have to calculate value of dy by dx on right side. Means completely left side term will should be dy by dx, right side term will be what is value there in terms of x or y, that will be required derivative of y with respect to x. This is procedure differentiate implicit functions. Means we have to differentiate given equation, we have to collect the term dy by dx, and lastly we calculate value of dy by dx. We will see this in third type example. Now with third type, we have to find dy by dx, and here given equation is root x plus root y equal to root a. Now we will consider given equation as it is root x plus root y equal to root a. Means in this type there are all examples of implicit function. In implicit functions, some functions are can be solved by procedure of explicit function and procedure of implicit function. Now this is in terms of equation. We often have regular our habit that we write the given expression as y equal to, but in this type of examples there is no need to write let y equal to, because there already this is equation. In all previous example there are all are expressions. Means in equations there is no need to write let y. Now how we can solve derivative of y with respect to x? Now we have to, here first step is we have to direct differentiate. Above equation with respect to x. Means what is derivative of root x here? Derivative of root x is 1 divided by 2 root x. What is derivative of root y? Composite function formula we use here, 1 divided by 2 root y into dy by dx. What is derivative of root a? Some students write it as 1 divided by 2 root a, but this is constant function and its derivative is c. Now you have to write on left side value of dy by dx. So we will take this first term on right side, like this. Now to calculate value of dy by dx, we have to multiply this equation throughout by 2 into root y. This 2 will be get cancelled and we get minus root y divided by root x. This will be the required derivative of y with respect to x, and in this expression we can also write this as 1 root sign in terms of 1 root sign, or like this. These two answers are acceptable. And this is solution of first example. In similar manner, we will solve the second example. First of all, we consider given equation x into root x plus y into root y equal to a into root a. Now first of all we will write 1 power for each expression. X raised to 1 into x raised to 1 by 2 means x raised to 3 by 2 is there, plus y raised to 1 into y raised to 1 by 2, root y means 1 by 2. 1 plus 1 by 2, 3 by 2 is there. A raised to 1 into a raised to 1 by 2, 1 plus 1 by 2, 3 by 2. Now this is equation in terms of all terms has 1 power. Now we will differentiate above equation with respect to x. Means what is derivative of x raised to 3 by 2? 3 by 2 power into multiplication. 3 by 2 minus 1 means 1 by 2 will occur, plus 3 by 2 into multiplication. Y raised to 3 by 2 minus 1 means 1 by 2, and into again dy by dx should be there from the input function. Again derivative of a raised to 3 by 2. Derivative of a raised to 3 by 2 means 3 by 2 into a raised to 3 by 2 minus 1 is wrong, because a raised to 3 by 2 is constant and its derivative is 0. Now by dividing this equation throughout by 3 by 2, we can again write this as root x plus root y into dy by dx equal to 0. 3 by 2 will get cancelled. Here we get root y dy by dx equal to minus root x. And again we get here dy by dx as minus root x divided by root y, or one sign of root, we can write this as required derivative of y with respect to x. In this way you can solve examples of implicit functions. Third example of implicit function is here. Now here x cannot be expressed explicitly in terms of y, or y cannot be expressed explicitly in terms of x, therefore this is implicit function. Now we have considered this implicit function as it is. Now this procedure of differentiation of implicit function, we have to differentiate directly this type of function with respect to x. What is derivative of x here? Derivative of x is 1. What is derivative of root xy? We have to use formula root f of x derivative 1 divided by 2 root f of x into d by dx of xy. Thus derivative of y with respect to x. What is derivative of y? dy by dx, and derivative of 1 is 0. Now we will calculate derivative of xy. We will use the product formula. First function x as it is, derivative of y with respect to x, plus y as it is, derivative of x is 1, plus dy by dx as it is on the right side 0. Now we will separate the terms of dy by dx and individual terms. What are individual terms here? Individual term is 1 plus, we have to multiply these two terms by 1 by 2 root xy. This first term will be, we will first of all write separate terms. 1 divided by, this first term will be x divided by, x divided by 2 root xy divided by dx, second term, third term plus y divided by 2 into root xy plus divided by dx equal to 0. Now here x divided by root x means this term will occur 1 plus x divided by root x is here, means here 1 root x will occur because x can be written as root x into root x and denominator root x as it is, therefore only 1 root x will be applied. Now here you can write 1 plus root x divided by 2 into root y only remain divided by dx plus in third term will also use same procedure. So here we get root y divided by root y means root y divided by root x, last term divided by dx equal to 0. Now we will collect the terms of divided by dx, therefore we get root x divided by 2 root y plus 1 into divided by dx minus all terms on right side, minus will be common, 1 plus root y divided by 2x. Now cross multiplication, root x plus 2 root y divided by 2 root y into divided by dx equal to minus cross multiplication here 2 root x plus root y divided by 2 root x. Now we will calculate value of divided by dx by multiplying dot equation by 2 root y divided by root x plus 2 root y. Means left side term will be only divided by dx, right side term 2 to cancel. So here we get root y divided by root x, root y into multiplication term will be 2 root x plus root y. Denominator term will be root x into root x plus 2 and minus sign is there. Therefore this is required derivative of y with respect to x. Again see the calculation of this side. We have taken divided by dx common, root x divided by 2 root y plus 1 will be remain here into divided by dx, and these two terms are written on right side by taking minus sign common, 1 plus second term is as it is because we have taken minus sign from both terms common. Now by taking cross multiplication, root x plus 2 root y divided by 2 root y, on right side also 2 root x plus root y divided by 2 root x. Now by multiplying reciprocal of this term, we get required value of divided by dx as 2 will get cancelled, root y into this bracket term, root x into this bracket term. This is required derivative of y with respect to x. This is solution of third example. Now we will solve fourth example. Fourth example is x cube plus x square y plus xy square plus y cube equal to 81. We have written this given equation as it is in consideration. Now to solve these implicit examples, implicit functions, first of all we will differentiate above equation with respect to x. Then what is derivative of first function? Derivative of x cube is 3 into x square. Now to find derivative of this function, we have to use product formula. This first function as it is, derivative of y with respect to x plus y as it is, derivative of x square is 2x. Now derivative of xy square. This first function x as it is, derivative of y square is y square divided by dx. We are calculating derivative of this function. First function derivative of second plus second function y square is derivative of x is 1, and next term y cube. Derivative of y cube is 3y square into dy by dx, and right side derivative one is in this all these terms we will collect the terms of dy by dx and individual terms. Which are individual terms? 3x square, 2xy and y square. We will collect these terms. This next equation will be 3x square plus 2xy plus y square. We will write this term like that. Now, which are here terms of in terms of dy by dx? We will collect their terms. We will collect their terms. Dy by dx first term is coefficient is x square, second plus 2xy, and lastly plus 3y square. And right side term is 0. Now we have to calculate value of dy by dx. Therefore we get x square plus 2xy plus 3y square into dy by dx. We calculate value of this term will be equal to minus 3x square plus 2xy plus y square. So only we have taken this bracket on right side. Now our required value of y with respect to x is minus this term as it is and divided by this coefficient will be in denominator x square plus 2xy plus 3y square, and this is required derivative of y with respect to x means solution for implicit function of 4th example.